Okay, the next problem you had was on page 574, number 22. It says when the angle elevation to the sun is 82 degrees. So remember, elevation, you have to have a horizontal distance first. And here's my sun, and so elevation means the angle above is 82 degrees. The monument, so I kind of drew up my makeshift monument, casts a shadow that is 5.1 feet long. So you know a shadow casts downward. So here is the shadow, 5.1 feet long. What is the height of the monument? That's X. So with angle elevation and depression, this is when you go back to chapter 3 and you're kind of using your alternate interior angles, because we have a horizontal distance, which means the lines are parallel. So up here you kind of have an invisible parallel line. So if this is 82 degrees for the angle elevation, that means up here the alternate interior is also 82 degrees. And so we're only looking at this triangle right here because we're trying to find a monument. If this is 5.1, then this is also going to be 5.1. So I'm kind of flipping all of my stuff so that I'm able to kind of just look at this triangle only. So alternate interior angles, how I got this 82 up there, and then this 5.1, so that's 5.1. Got it? So then with this figure, we have opposite. So tan 82 degrees equals opposite over that adjacent angle. So that's my opposite, that's the adjacent angle. And so we multiply both sides by the coefficient, by the denominator. That cancels, and so I put 5.1 times tan 82 degrees in the calculator, and on number 22, this is going to equal a 36-foot monument. Got it? Okay, here's number 23. 23 says, a ranger standing in a lookout tower. I drew a little man on top of a lookout tower. Yeah, I know, corny. He spots a fire in the distance. The angle of depression. So depression, here's his horizontal line of sight. Depression is going to be below. Angle of depression is 4 degrees. And the lookout tower is 32 feet tall. So I already labeled that. What is the horizontal distance to the fire? So basically trying to figure out that horizontal distance to the fire. Remember, alternate interior angles, if this is 4, this is also 4 degrees. Opposites are congruent. We want to know the horizontal distance. So we're going to use tan 4 degrees because I have opposite over that adjacent angle. Why am I putting A? Okay, that'll be my unknown. A instead of X. I don't know why I wrote A. So we have opposite over the adjacent. Remember, these basically flip-flops, so our unknown is equal to 32 over tan 4 degrees. So I do 32 divided by tan 44, and that is equivalent on number 23 to 458 meters. So that is his horizontal distance from the fire. Oh, you can't see. Sorry. There we go. Got it? Okay. That is angle of depression, angle elevation. That takes practice, being able to draw these beautiful pictures like me. Here's number 24. Find each measure, round lengths to the nearest tenth, and angle measures to the nearest degree. In this figure, we see that it is an obtuse triangle. And what does that tell us? We will not be using our trig ratios, sine, cosine, and tangent, because it's not a right angle. We're going to be using our law of cosine or law of sine because it is an obtuse or an acute triangle. So let's look at what we're given. We're given a side, side, and an angle. So if you go back to the law of cosine and sine, side, side, angle tells us we're using the law of sine. And all the law of sine is just proportions. Since we're finding z, you're basically, since it's sine, we're using sine. 40 is opposite of 7, so our proportion will be sine 40 degrees divided by whatever side it's opposite of, which is 7. It's a law of sine because it's not a right triangle and it's a side-side angle. And then here we don't know that one, so that's going to be sine inverse of x because we don't know that angle. And that one is opposite of 4. And so the law of sine, you're just doing a proportion, which means we cross multiply. So we have 4 times the sine of 40 degrees. And then cross multiply that one. And that's going to be equal to 7 times sine inverse of x. Trying to figure this sine inverse out, so we're going to divide both sides by 7. And so sine inverse is going to be equal to 4 times sine 40 divided by 7. So I'm going to put that in my calculator. 4 times sine 40 degrees. And then I divide that answer by 7. And so that means the sine inverse of x is going to be equivalent to about, I'm going to use a couple of numbers, 4, 6, 7, 3, just so I can get a little bit more accurate. And then I'm going to do sine inverse of that answer. And so our answer is equal to 22 degrees on 24. And that is the law of sine. Got it? Pause it if you need to. Okay, let's look at 26. 26, we look at it, and it is an acute triangle. I'm going to flip it. I know y'all's is upside down. G is worth 101. G to E is worth 14, and G to F is worth 12. And when you look at it, we have side, angle, side. And side, angle, side tells us we're using the law of cosine. Law of cosine is not hard. People get confused by it, but it's easy. Why? Because I only really use the one with the Pythagorean theorem. C squared equals A squared plus B squared. You have to memorize this, so that's why I use the Pythagorean theorem. And then it's minus 2 times those two legs, AB. It's the law of cosine, so that's when the cosine comes in, and we're doing cosine of that outside unknown, which is C, capital C. So it's C squared equals A squared plus B squared minus 2 times A and B cosine C. And that is the law. So now let's look at what we're given. So in 26, we're trying to find EF. That's our unknown. So since that side is our unknown, that will be the C squared, the outside, the unknown. We're given our AB. So we have 12 squared plus 14 squared minus 2 times, and we're going to take that 12 times the 14, those same two legs, just not squared. And then the cosine of what angle? Our unknown is opposite of 101 degrees. Got it? So then I do 12 squared plus 14 squared, and that is equal to 340 minus 2 times 12 times 14, and that is going to be 336 cosine 101. Like I told you on the workshop or the video, the biggest mistake made with these two is people want to go ahead and split them up. You can't. They're multiplied. So what you have to do here is basically do it separately. So I'm going to do 336 times the cosine of 101 degrees. And that is going to give me 340 minus, and 336 times cosine that is negative 64.111. Two negatives make a what? Positive. So basically we have 340 minus that answer. And so on number 26, I did something wrong. Oh, what did I do? Let me pause. I didn't do anything wrong. I'm just stupid. Okay. Here we go. Okay, so C squared equals 340 plus that, and you should have got C squared equals 404.111, whatever. To get rid of C squared, we take the square root, and so your final answer is C is equal to 20.1. And that is your answer. Pause it if you need to take a little time to understand. Okay, on number 27, we have another acute triangle. And if you look at it, this one is a side, side, side. And so side, side, side tells us we're using the law of cosine. Law of cosine again. This one wants us to find Q. So Q is opposite of the 10. So since that's our unknown, that means the 10 is going to go on the outside. 10 squared equals 6 squared plus 12 squared minus 2 times that 6 and that 12 again. And remember, it's the law of cosine. And we do not know our angle, so this is going to be cosine inverse. And I'm going to put Q since that's what we're looking for. So the opposite of our unknown is 10, so that's why 10's on the outside and the cosine Q is there. So now it's just calculating. 10 squared is 100. 6 squared plus 12 squared is 180. And then negative 2 times 6 times 12 is going to be a negative 144 cosine inverse of Q. Here in this problem, we're trying to get Q by itself, so we have to move everything else. So we subtract 180 on both sides, and this becomes negative 80 is equal to negative 144 cosine inverse of Q. Divide both sides by negative 144. Why are we dividing? Because we have to separate that negative 144 in the Q. And so cosine inverse of Q is going to be equivalent to negative 80 divided by negative 144. And so I'm going to do the cosine inverse of that answer. And so you should get that Q is equal to 56 degrees. Got it? All right. The next problem was number 2 on page, what was it? Hold on. Number 2 on page 580. So it says we have a triangle A, B, and C. It is a, oh, I cannot read. Sorry. It is a right triangle. ABC is a right triangle. Angle A is worth 20 degrees. Angle B is the 90 degrees. I'm assuming we don't know C. Let me zoom in a little bit on that for you. It says AC is 8, AB is 3, and which expression can be used to find angle BC? So let's look at what we're given so we can figure it out. We're trying to find BC, so we don't know the opposite. We do know the adjacent, so that means tan 20 degrees is equal to opposite over adjacent. I look at my answer choices, that does not exist, so the answer seems like it's in X form, so of course we multiply both sides by 3 to get rid of that denominator. And so let me see if 3 times tan 20 is there. No, it is not. So then that means I have to use another one. Let's try another one. We also given the 8. So let's see, we're looking for BC. So we know that opposite and hypotenuse means we could try sine. Sine of 20 degrees equals, opposite over hypotenuse. Multiply both sides by 8. And does 8 sine 20? Nope, that one doesn't show up either. All right. Am I on the right track? Okay, that one doesn't show up either. I see 70 in the answer choice, so this is something I did. So we know this is 20, 90, so that means this is 70. So let's try that one. Tan 70 degrees equals opposite, which is 3, over the adjacent that we're looking for. Remember, when x is in the denominator, we basically flip-flop it, so x equals 3 divided by tan 70, and that is the answer, F. And so that one works. So it's multiple ways to solve a problem, so this is kind of showing you got to kind of go through all of them and figure out which one works.